just get right into it. So these are the ones that we barely practiced at the very end of class last time. So we're going to get more into it and practice them even more today. So we're on page 2 of 5-2. Does everybody have that, and is everybody there? All my examples are coming up your worksheet, so it'd be really not smart of you to not be there with us. Okay, so it says in the instructions, rationalize the denominator of each expression, assume all variables are positive. So just one thing to note, guys. One thing that we do with division is always see if they can simplify first, like put them together. That's what we talked about last time. So do you see how if these are both under a square root, if we put them together, they don't simplify? Does everybody see that? So when that happens, you have to break them back apart. So we'll just leave these apart, and you say to yourself, is this answer acceptable? If that didn't simplify, then that's your answer. But is your answer acceptable? So you would say no, because we have a radical in the bottom of a fraction, it's not considered simplified. Does everybody understand? Okay, so let's rationalize the denominator. That means get rid of the rational in the bottom of our fraction. So this is a square root. Don't we need it to be the square root of something squared? So that root cancels out with power. So how many more 5s do we need? 1. So we're going to multiply by the square root of 5. If you do that to the bottom, you've got to do it to the top. Okay, so then from there you'd say to yourself, okay, I'm going to look and focus on the top part here. Can I multiply those together? The answer is yes. We'll put them under the same root, the square root of 5y. Now, that didn't simplify because there's not 2 of them to pull out. If it did simplify, we would. Now, on bottom, we have the square root. I'm going to write it over here. The square root of 5 times 5, which is 5 squared. Does everybody see how on bottom we have the square root of 5 squared? So we just have a 5. Now, you'd say, that is my answer, because I know I can never divide something under a root with something that's not, so that is my final answer. Now, guys, this answer and this answer are literally pretty much the exact same thing. They are the same thing. One is just considered more simplified than the other. Everybody good with that? Okay, let's do another one. You'll get more and more comfortable with rationalizing. Okay, look at 35. So notice how it says rationalize the denominator. It would be very smart for you to first put it together, simplify what you can, and then see if you still need to rationalize. So let's put this one together. So we're going to put it under the same square root. That's 18x squared y on top. And on bottom we have a 2 and a y cubed. Does everybody see how it's the exact same thing? I've just rewritten it under the same radical now. Let's simplify what we can. So 18 and 2 simplify, correct? This becomes a 1, and then 18 becomes a 9. Very good. Now x squared doesn't simplify, and then let's simplify our y's. 1y on top and y cubed on bottom. Won't that be y squared on bottom? So I'm going to rewrite that. Right now we have this, the square root of 9x squared y on top, and on bottom, no, not y, correct? Not y. We just divided out y. Sorry. The square root of 9x squared on top, and on bottom we have y squared. So you'd say to yourself, that doesn't simplify anymore underneath the radical, so now let's split it back up. Does everybody understand? Let's split it back up. So on top, I have the square root of 9x squared. And on bottom, I have the square root of y squared. So now let's simplify it in pieces. Let's just focus on the top and simplify the top. Can't we simplify the top? What's the square root of 9x squared? 3x, very good. And we're assuming all variables are positive, so we don't need to worry about absolute values. And on bottom, we simplify it and we get a y. Now you look and say, that's my final answer. Is there any problems? Is there any negative exponents? No. Is there any radicals on bottom? No. So we're done. We didn't even have to rationalize the denominator on this one. Everybody good? Okay, so that's my final answer. So remember, you can look at it in sections and split it back up and stuff. We put it together, simplified what we could, then re-split it back apart because we wanted to simplify it in sections. Does that kind of help a little bit with, yeah, okay. All right, let's do 37. Now notice, this one's already together. And notice, nothing simplifies underneath the root. So let's split it up so that we can simplify it in sections if possible. So on top here, we have the square root of 9x. On the bottom, we have the square root of 2. You'd say, that answer is technically not quite simplified yet. Doesn't the top kind of simplify? Well, part of it simplifies, right? 9? So won't it be 3 square roots of x on top? Now on bottom we have the square root of 2. Does the square root of 2 simplify? No. So you say to yourself, that is my answer because I've simplified everything I can. However, is my answer acceptable? No. So I'm just trying to help you guys see how you can think through like when you're done and when you're not done. Does everybody understand though that yes, simplifying wise, I am completely done here. All right, so you'd say to yourself, the only reason this answer is not acceptable is because we have a radical in the bottom. So we're going to rationalize my denominator. So we're going to multiply by the square root of 2 over the square root of 2. Now let's just focus on top. X and 2 are both under the square root, so we have a 3 on the outside. And underneath the root, we have an x and a 2, so I'm going to write it as 2x. We know that there's not 2 of 2's and not 2 x's, so nothing's going to pull out of the top more. Questions on the top part. And then on bottom, we'll have the square root of 2 squared, which is 2. So now you would just look and say, now that's my final answer. Does anything more simplify? Does 3 and 2 simplify? No, right? They don't divide out. And you can't divide something that's under radical with something that's not. So this would be my final answer. Everybody okay? Feeling better about these? Because I know there was one on the quiz that maybe a lot of us didn't get right. That's okay. We can fix it and get it right next time. All right, let's do 38. So once again, there's many different ways to do this. You could go ahead and rationalize it right now, but I always put mine together and simplify first. Does everybody understand? Okay, so let's put this together under the same root. So on top we have xy, and on bottom we have 3x. Now I'm going to ask you a question. Think very carefully before you answer it. Think about it. Is x connected to 3? Is it connected? It's connected by, so yes and no. So it's connected by multiplication, but isn't multiplication okay to divide out? Okay, so let's divide out those x's right away. Nice. One less thing, we've now simplified one thing. So now you say to yourself, left under my root is y over 3. So you say to yourself, that is my final answer. Pretty much, yeah, right? It is. But is that an acceptable answer? So let's split it up. We have the square root of y over the square root of 3. And neither of those simplify anymore. So you say to yourself, that's my answer. Is it acceptable? No. So our last step is to say, that is the simplified answer, but we've got to rationalize the denominator. So we'd multiply by square root of 3 over square root of 3. So on top, we're going to get the square root of 3y. And on bottom, we're going to get 3. And you can't divide something that's under a root with something that's not. Is this all making sense on how your thought process should be? Okay, awesome. I think you're going to do great. So, one more that's a little bit more difficult. Everybody look up here. Notice these are both under a cube root. Notice nothing simplifies, correct? So then you are going to split it apart and then look at it in pieces. So let's split this apart. On top we have the cube root of 3a. On bottom we have the cube root of 4b squared c. On the quiz next time, there will be one about this level. So you'd say to yourself, that is my answer because it didn't simplify. Does 3 or a simplify on top? Nope. On bottom, can we pull out anything? No. So you'd say to yourself, that's my answer, but is my answer acceptable? No, we can't have a radical on bottom. So we've got to rationalize the denominator. Now I want to remind you of something. To rationalize something like this, we just need 3, since it's a cube root, we need the base raised to the third power so it cancels out. So isn't 4 the same thing as 2 times 2? So I'm going to remember to write this as this. 4 is 2 times 2, b squared is b times b, and then we have a c. I'm going to rewrite it like that so that when I rationalize, I'm doing it by the least amount of things possible. Does everybody understand? Okay, so let's rationalize the denominator. We're going to multiply by the cube root of, we have 2 2's, we need that to be 2 cubed, correct? So how many more 2's do we need? 1 more 2, very good. We have 2 b's, we need it to be b cubed. How many more b's do we need? Good. Now we have 1 c, we need it to be c cubed. How many more c's do we need? So c squared. Can I write it as c squared and not confuse anybody? That's c times c, right? Okay, let's do that to the top then, because you can't only do it to the bottom. So we're going to multiply by cube root of 2bc squared. So now you'd say to yourself, okay, let's multiply straight across on top. So on top, I have the cube root of 3 times 2, which is 6. We have an a, no other a's. We have a b, no other b's. And we have a c squared. Nothing of that can simplify more on top, correct? We can't pull out any groups of 3. And now on bottom, I'm going to go off to the side. We have the cube root of 1, 2, 3 2's. That's 2 cubed. We have 1, 2, 3 b's. That's b cubed. And we have 1, 2, 3 c cubed. So don't the roots cancel out the powers. So left on bottom is 2bc. So you'd say to yourself, now is my answer simplified all the way? Yes, because you can't divide something under root with something that's not. So there's my final answer. Yes. Good question. 6 breaks down into 3 and times 2 and then nothing more, right? We have to pull out groups of 3. There's not 3 3's, there's not 3 2's. So we leave them underneath as 6. Good question. Any other questions on that? Okay. Awesome. Okay, do problems 34 through 42 as practice. Ready, set. So we're now on page 3 of 5-2. Okay, number 1, add or subtract if possible. 9 square roots of 3 plus 2 square roots of 3. Square root of 3 is square root of 3. So they're like terms. How many square roots of 3 do we have? 9 plus 2 is 11 square roots of 3. We have to have the same radical and the same base for it to be the same, right? To be able to add them. Hey, 5 square root of 2 plus 2 square root of 3. Can we add these? Nope. Square root of 2, square root of 3. They're not like terms. That's an x and an x squared. An example. They're not the same, so we can't add them. Correct, everybody? So you can't add these. Number 4, we have 14 cube roots of xy minus 3 cube roots of xy. Are they like terms? Look at the apple. It is the same. So how many cube roots of xy do we have? 14, 13, 12, 11, right? 11 cube roots of xy. 14 apples minus 3 apples is 11 apples. The apple part does not change with addition and subtraction. So let's look at number 8. 6 square roots of 2 minus 5 cube roots of 2. Cube roots, square root. Can we combine them? Nope. We could multiply them, but we cannot add and subtract them. So we just say can't. Okay, so do problems 1 through 9. I'll give you a couple minutes to finish up 1 through 9. Okay, right here it says simplify if possible. So right now it looks like we can't add them, but they're not simplified. So these are, we can't tell until we have them all simplified. Quickly, 75 breaks down into 25 times 3, right? 25 breaks down into 5 times 5. So we'll pull out a 5. There was already a 3. So doesn't this piece simplify to be 15 square roots of 3? Everybody feeling good? Let's move on to this one. 4 times 3. 4 breaks down into 2 times 2. So we'll pull out a 2. There was already a 2. So we have plus 4 square roots of 3, correct? So now you say to yourself, now that I simplified, are they like terms? Yep, 15 plus 4 is 19. So our final answer is 19 square roots of 3. So in order to be able to tell if you can add or subtract them, they do need to be simplified. All the way down. Just a reminder. Okay, so do 10 through 18. Okay, so next section is we're multiplying 2 things. Now notice, everybody look. This has 2 terms. Remember, terms are separated by plus or minus signs. This has 2 terms. You're going to have to say, I'm multiplying all this stuff to all this stuff. So you're going to have to double distribute because there's 2 terms in each thing. So it's a binomial multiplied by a binomial. So we know if we have x plus 2 times 3x minus 1, we got to focus on x, double distribute it, correct? Then we've got to focus on 2, double distribute it, and then we'll combine like terms. We've got to treat this problem the same because there's a binomial and a binomial. Does everybody see that? So let's do it. Here we go. These are just where people mess up from being like not very careful. So what's 1 times 2? 2. What's 1 times the square root of negative 5? Negative 1 square root of 5, correct? Now we'll move on to negative square root of 5. Very carefully. Negative square root of 5 times 2 is negative 2 square roots of 5, correct? Now careful, right? Here's where people always mess it up. Negative square root of 5 times negative square root of 5 is positive square root of 25. So now you're going to simplify what you can. We have 2 minus 3 square roots of 5, and then we have plus 5. Isn't the square root of 25 5? So combine like terms. 2 plus 5. We always read these from left to right. People will see the negative in back of the 2 and think that's negative 2. That's positive 2 plus 5. That's 7, correct? So we'll have 7 minus 3 square roots of 5. Any questions on that? So now that's kind of putting it all together. Can you multiply correctly? Can you combine like terms correctly and whatnot? Number 20, let's do another one. We would distribute. We've got to be very careful. You can do it. 1 times 2 is 2. Very careful here. 1 times the square root of negative 10 is negative 1 square roots of 10. Then we're going to have 4 square roots of 10 times 2. That's positive 8 square roots of 10, correct? Plus 8 square roots of 10, and then very careful because this is usually where people mess it up. The square root of, so positive 4 square roots of 10 times negative 1 square roots of 10 will be negative 4 square roots of 100. So let's simplify what we can. We have 2, negative 1 square roots of 10 plus 8 square roots of 10 is plus 7 square roots of 10, correct? Now we have negative 4 times, what's this? This is negative 4 times 100, square root of 100. Which isn't that the same thing as negative 4 times 10? Right? So that's 2 plus 7 square roots of 10 minus 40. So combine like terms. Negative 40 plus 2 is negative 38. So we have negative 38 plus 7 square roots of 10. Can we do those by ourselves now? Okay, I'll have you practice a few then. Okay, on 23, I'm just going to talk about this really quick. Is it appropriate if I look at something like this? Is it okay to just say, I'm going to just square that, square that? No. No, because that's breaking the forbidden rule, correct? There's a plus sign, there's 2 terms. If there's 2 terms, you have to split it up. That's not right. You've got to split it up and write it as x plus 2 times x plus 2. So number 23, we would not break the forbidden rule and just square that, because there's a plus sign. We rewrite it as the square root of 2 plus the square root of 7 times the square root of 2 plus the square root of 7. Let's continue this one real quick and then I'll let you work. Sorry. Last one. Then I'll let you go for it. So let's multiply this out correctly here. Don't let these things throw you off. Go with the math. Like if something feels weird, say, no, I know what I'm doing. I'm going to go with it. Square root of 2 times the square root of 2. That's the square root of 4. Let's keep going. We'll simplify later. Square root of 2 times the positive square root of 7. Isn't that positive square root of 14? Okay? So don't let, where did my little page extender go? All right, I can't scroll down apparently. I don't have my page extender anymore for a second. Then square root of 7 times square root of 2 is positive square roots of 14, correct? Positive square root of 7 times positive square root of 7 is positive square root of 49. You say to yourself, does anything simplify? Square root of 4 is 2. Then we're going to have plus 2 square roots of 14, because those are like terms. And then plus the square root of 49 is 7. So we'll combine like terms. 7 plus 2 is 9. So our final answer is 9 plus 2 square roots of 14. So if something feels weird, just go with the algebra. You know if you're multiplying it out right, so it's going to come out right. So don't let little things that just look a little different throw you off, if that makes sense. Okay. So what I'm going to have you do is 19 through 30.